them showing for themselves. That's what they do.
The idea that God created the universe went largely unchallenged until the Middle Ages, when scientists made a sacrilegious suggestion based on their observations. The sun, not the earth, was at the center of the universe.
It was a paradigm shift. There is no another way to explain the naturally occurring phenomena around us, and this is science.
Since the Middle Ages, scientists have developed sophisticated new theories about the enormity of the universe and our place in it. Theories that often have no room for God.
Many phenomena have appeared mysterious or miraculous or magical. And then through the process of science, we've eventually understood them. Scientists gradually realized that the sun really is just one star among a multitude of stars in a gigantic galaxy having hundreds of billions of such stars. And all this was created in a Big Bang 13.7 billion years ago.
But while scientific theories, observations, and experiments tell us where we are in the cosmos, they don't answer the eternal questions. Why we're here, and who, if anyone, created us.
The amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stars. You couldn't be here if the stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution weren't created at the beginning of time. They're created the nuclear furnaces of stars, and the only way they can get into your body is if the stars were kind enough to explode. So forget Jesus, the stars died so that you could be here today. Okay? And anyway.
By the end of the 1920s, astronomer Edwin Hubble, working with the large 100-inch telescope atop Mount Wilson outside Los Angeles, had established that our galaxy was only one of many galaxies in the universe.
We look out at other galaxies, on average they're moving away from us. And those that are twice as far away are moving twice as fast, and those that are 3 times as far away are moving 3 times as fast. And of course that makes us look like we're in the center of the universe.
Such a condition would imply that we occupy a unique position in the universe, analogous, in a sense, to the ancient conception of the central Earth. This hypothesis cannot be disproved, but it is unwelcome and would only be accepted as a last resort in order to save the phenomenon. Therefore, we disregard this possibility. The unwelcome position of a favorite location must be avoided at all costs. Such a favorite position is intolerable.
Several decades ago, we found a problem so great that it was pushed under the carpet for many a decade. And this is the fact that galaxies spin too fast. In fact, 10 times too fast. By rights, the galaxy should fly apart. Therefore, scientists said that we have to have dark matter, a halo of matter that surrounds the galaxy and holds the galaxy together. And what have they discovered? Absolutely nothing. Zilch. What is a little bit turning in the last 50 years we still haven't found what the Delta Group. But on the other hand, that doesn't mean they're not there, it just means they're harder to find than we thought.
You look out at the universe, 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, and taste. And it doesn't add up to give us the gravity that we see operating. So really we should be calling it the dark force. Because we don't know if it's made of matter. It could be a profound misnomer, sending people off in thought directions that might not really be the right path. So dark matter is simply what we call this thing about which we know nothing, responsible for 85% of gravity. It is the longest standing unsolved problem in modern history. Dark matter, dark energy. Everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid.
So the problem with cosmology is that we keep inventing theories, ad hoc theories, we try to explain the data, such as inflation, dark matter, dark energy, and so on, just to keep patching the theory up.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.
A very large number of universes, perhaps even an infinite number, could in principle exist in a vast hyperspace.
We can understand the idea of hyperspace by comparing it to a mug of beer.
The beer mug in a hyperspace and the bubbles between these individual universes. The bubbles in a beer mug are all physically about the same, but suppose they span a range of properties. Some of them might have carbon, oxygen, and stars and gravity, and others don't. We would be in one of the ones that leads to a rich, complex universe culminating with life as we know it.
If there are an infinite number of other universes, the fine-tuning that seems to be present in ours isn't an example of God's plan, but rather the law of statistics. Most of these universes would naturally develop in ways that fostered intelligent life, but a few would.
So then the explanation of the specialness of the universe is that we are winners in a gigantic cosmic lottery. It stands to reason that we couldn't be living, discussing this in a universe that was hostile to life. Only the biofriendly ones get populated with thinking beings.
Having a multitude of universes is actually quite a simple and natural consequence of some of the most favored models for the birth and early evolution of our universe. It's kind of like stars and planets. As long as you have the capacity to make one, it's easy to make lots of them.
Oh, really? Wow! Beer mug hyperspace multi-bubble really? Yeah. Seriously? They're farting out beer bubble universes. Okay, that's what they're doing. Hey, I got your turn. Yep. Beer bubble universe. And they call that science. And they make fun of us? Really? Yeah, I'm not going to take that from them. I'm not going to sit here and let people who think they came from monkeys out of a beer bowl universe ridicule me for looking into what I'm looking into and considering, a possibility. If you guys can think about beer bowl universes, then I can think about a snow globe. Fair enough? Okay, let's move on. That's what they believe, that's what they teach. They're realizing how absurd their own theories are. They have one ad hoc theory upon another to try to justify the things that they can't, they find no observation out there, for themselves. It's just ridiculous. I mean, Tesla started to see this happening even in his day. He's quoted as saying, today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. They say, I'm a theoretical physicist. Whenever you hear that, they're working on a chalkboard. Okay, that's it. They're working on a chalkboard. In fact, there's a documentary that William Shatner did. Okay, he was interviewing people like Mitch Kaku and others, as only William Shatner can do, right? He's coming up to these guys, he's like, what do you do? What do you do? He comes to the conclusion, it's all in his head. The guy just makes stuff up. And Shatner later is quoted as saying, what, science and science fiction are the same thing. It's all imagination. That's what it's turned into. And going back, even further, back into the 1800s, Robotham started to see it too. Samuel Robotham said that the whole system of Newtonian astronomy taken together constitutes a most monstrous absurdity. It is false in its foundation, irregular, unfair, and illogical in its details, and in its conclusions. inconsistent and contradictory. Because the Newtonian theory is held to be true, they are led to reject the scriptures altogether, to ignore the worship and doubt and deny the existence of a creator and supreme ruler of the world. It goes on to say that the scriptures were not intended to teach science truthfully is, in substance, to declare that God himself has stated and commissioned his prophets to teach things which are utterly false. And he's right. He's making an honest assessment there. And even other people within secular science are starting to take a hard look at what their discipline is teaching and saying, you know, we got problems here. This is an article that just came out April 30th this year. A guy wrote an article for Scientific American called "Cosmology has some big problems." In that article, he says the modern cosmology is in a serious need of a reboot. Compounding this problem, most observations of the universe occur experimentally and indirectly. Today's space telescopes provide no direct view of anything. They produce measurements through an interplay of theoretical predictions and pliable parameters in which the model is evolved every step of the way. In other words, they go in with a preconceived bias. The model they already believe, I think that's only what religious people do, believe, and then they create something, and everything they do is based on something that they already have a preconceived bias to. The framework literally frames the problem. It determines where and how to observe. And so, despite the advanced technologies and methods involved, the profound limitations to the endeavor also increase the risk of being led astray by the kind of assumptions that cannot be calculated. He goes on to say, a key piece of the Big Bang paradigm was criticized by one of the theory's original proponents for having become indefensible as a scientific theory. Why? Because inflation theory relies on ad hoc contrivances to accommodate almost any data, and because its proposed physical field is not based on anything with empirical justification. This is probably because a crucial function of inflation is to bridge the transition from an unknowable Big Bang to a physics we can recognize today. So, is it science or a convenient invention? He concludes his article by admitting, in order to maintain a mathematically unified theory valid for the entire universe, we must accept that 95% of our cosmos is furnished by completely unknown elements and forces for which we have no empirical evidence whatsoever. That's an honest dude right there. Taking a look at seculars. It's not a creationist, it's not a Christian if they're saying that. This is a guy taking an honest look at his own profession. And basically, I distilled it all down and said, what is taught today as fact is really nothing more than unproven ad hoc theories based on presuppositions derived from outlandish conjecture, which itself was contrived from sheer fantasy, all of which ends up beautifully illustrated by the hands of artists and published in textbooks as self-evident truth. That's where we're at today. So let's talk about this whole model that we've been taught in school. How old is the Earth and how do we know? Well, we got to look at the whole, there's two things that were proposed, catastrophism and then later uniformitarianism. From 1830 to 1833, his multi-volume Principles of Geology was published. The work, this is Charles Lyell. Okay. The work's subtitle was an attempt to explain the former changes of the Earth's surface by reference to causes now in operation. He was, along with the earlier John Playfair, the major advocate of James Hutton's idea of uniformitarianism, that the Earth was shaped entirely by slow-moving forces still in operation today, acting over a very long period of time, as opposed to catastrophism, an idea of abrupt geologic changes through violent action. Thus, basically, Charles Lyell looked at the stripes in the rock, like the Grand Canyon stuff, and he assumed that must have taken millions of years. Just assumed it. He had no proof, and no dating methods or anything like that. He just assumed it. Today, this is the accepted view of geology. But how accurate is this assumption, and how reliable are our dating methods today? Consider this.
What about the age of the Earth? Isn't there evidence for millions of years? And how do we understand all that? Well, first of all, let's look what the Bible says. If you take the days of creation as all 3 days, and you take all those genealogies in Scripture, if you add it all up, 5 days before Adam, from Adam to Abraham, and then you add up from Abraham until today, you get about 6,000 years. Now, if the Bible said the Earth is 6,000 years old, there'd be a problem, because it was completed 2,000 years ago. So you see, the Bible doesn't say, here's how old the Earth is. You know what the Bible gives us? A history. and it tells us about the days of creation, when people lived and died and so on, and gives us that history so we can add up the dates, and that's how we get a few thousand years. But what about all the dating methods that seem to indicate billions of years? Actually, there are hundreds and hundreds of dating methods that you can use to age date things on the Earth. See, one creation scientist I know makes this statement. He says 90% of the methods you can use to age date things on the Earth contradict the billions of years. Only 10% even seem to give the billions of years. But all dating methods have fallible assumptions. Who's heard carbon dating used to supposedly prove millions of years? Put your hand up. You know, there's a misconception out there in the culture. Do you realize that carbon dating has nothing to do with millions of years? It can't do. Any secular scientist who understands carbon dating will tell you the same. It's got nothing to do with being a creationist or an evolutionist. Carbon dating has nothing to do with millions of years. Nothing. In fact, carbon-14, after about 100,000 years, when you understand radioactive decay, the half-life of carbon-14 is only a few thousand years. So after about 100,000 years, if carbon-14 will be not detectable. Here's how carbon-14 can be used. If something is millions of years old, it shouldn't have radioactive carbon. It should have all gone. Let me just do another example here of radioactive decay for you. This is just basic principles. It's so much more complicated than this.
Nearly every textbook in Science magazine teaches that the Earth is billions of years old, and the primary dating mechanism for determining this is what is called radioisotope dating, or radiometric dating. Now, this is a reliable method for measuring absolute ages of rocks or the age of the Earth, right? First of all, many scientists now regard the age of the Earth as between 4.55 and 4.6 billion years old. Okay, so if this method is reliable and accurate, why the 15 million years old? That seems like a lot. But let's get into some details here and see what's going on. Keep in mind, there's all kinds of scientific jargon on this topic, and so we'll just present a very straightforward, simplified version. Radiometric dating is the process of estimating the ages of rocks based on decay and other kinds of analysis. For instance, uranium will radioactively decay through a series of steps until they come to the stable element called lead. The original element is called the parent element, and the end result is called the daughter element. Radioisotope dating is common in dating these rocks which form when hot molten material cooled and solidified. The dating clock started when the rock cooled. During the molten state, it is assumed that the intense heat forced any gaseous daughter elements to escape. It is assumed that once the rock cooled, no more atoms escape, and any daughter element now found in the rock is a result of radioactive decay since that rock formed. The decay rate is measured in terms of half-life, that is the length of time it takes half of the remaining atoms of the radioactive parent element to decay. Now, of course, that can be measured in a laboratory, and it is assumed that since we know the decay rate, we can calculate backwards and come up with the age of the rock. But is that all there is to it? Here's where it gets tricky. It's true we can measure a decay rate using observational science, but there's another kind of science that is required to accurately calculate the age for rocks, and that is what we call historical science. Historical science deals with the things of the past, and therefore it cannot be repeated and tested. Dating methods require both types of science, because in order to get accurate rock dates, one would have to accurately know both the decay rate and the initial conditions of the rock sample, right? Since radioisotope dating uses both types of science, we can't directly measure the ages of rocks. There are assumptions involved. For instance, how do we know what the initial conditions were in the rock sample? How do we know the amounts of parent and daughter elements now that sample haven't been altered by other processes in the past? How does someone know the decay rate has remained constant since the rock formed? The answer is they don't. Let's simplify here and talk about a typical hourglass. Let's say you walk into a room and you see an hourglass with sand at the top and sand at the bottom, and some sand sprinkling from the top sand to the bottom. Well, observational science will allow us to see and measure the sand, and then calculate how long the hourglass has been running, right? We can make our sand measurements and then calculate when the hourglass was turned over, right? Well, those calculations could be wrong, because we may have failed to consider some major assumptions, like, was there any sand at the bottom when the hourglass was turned over? Has any sand been added or taken out of the hourglass? Has the sand always been falling in constant rain? Since we did not observe the initial conditions when the hourglass started, and we haven't been watching the sand all the time since then, we must make assumptions. All three of those assumptions can affect our time calculations. Now, of course, there's more to understand about this, but
I'm here at beautiful Mount St. Helens in Washington State. You know, just about 40 years ago, this mountain was cone-shaped. But as you can see, it's not like that anymore. Now it's got this horseshoe shape. That's because on the 1980, of this volcano blew itself. Literally. The top of 1,300 feet of material blasted away, leaving this crater. Now eventually, lava flows formed 8 U-dots. 5 U-dots actually, all of which were destroyed by substance. But the sixth element formed between October 1980 and 86, which is what you see today, is composed of 2.6 billion cubic feet of lava, and it's quite young, having finished forming just over 100 years ago. Well, in 1996, geologists sent rocks from the lava dome to be radiometrically dated. Now, they used a method called potassium argon. Well, scientists measured how much potassium and how much argon are in the rock, and they calculate the age of the rock, right? But creation scientists have pointed out for years that there are some major problems with radiometric dating. One big one is all the assumptions that it's grounded on. You must assume that the half-life is constant and that it never varies. You have to assume that there was no contamination. For example, no argon was present in the cell before the Big Bang. Well, that's a lot of unprovable assumptions. Now, if radiometric dating and the assumptions that's founded on were accurate, well then Mount St. Helens rocks should have yielded very young ages. After all, the rock was merely a decade. See, the problem is, they didn't. The rock made 250,000 years. When they dated the minerals within the rock, the problem got much worse. They gave dates of 2.4 million years. This is for a 10-year-old rock. Now, Mount St. Helens highlighted that we shouldn't blindly trust the dates given by radiometric dating. The assumptions clearly are accurate, so the dates that they give are also inaccurate. Instead of trusting a method that doesn't even give direct ages for rocks of known age, well, maybe we should trust the Bible's history, which tells us that our Earth is around 6,000 years old.
Okay, so we've established the Big Bang cosmology is complete nonsense. By the own words, are 96% stupid and off by 10 to 120 power. And we've just seen the dating methods are completely unreliable. Let's consider another possibility for geologic formations that we see. And I would refer to something, the analogy that Kent Hovind used to say. He said, you can put two people looking at the Grand Canyon, a creationist and an evolutionist, and the evolutionist will say, wow, look at the Colorado River carved out over millions of years. And the creationist will say, wow, look what the biblical flood carved out in a matter of minutes. Big difference, right? Your preconceived bias will drive your conclusions. I already told you that I personally come from a biblical worldview, so let's look at what I would say is a much more plausible explanation for geological formations. There was a guy, how many of you heard of Emmanuel Peltoff? Amazing character. He lived around the same time as Einstein and those characters, and he was a big proponent for catastrophism. Coming against this whole idea of uniformitarianism. If you haven't read these two books in particular, these are books I read actually as a teenager and I revisited recently. The Worlds in Collision and Earth and Upheaval, highly recommend you check those out. But check this out.
The Earth's surface is scarred by deep canyons, cut into solid rock. But how did they form? A little bit of water over a long time, or a little bit of time with a lot of water? Modern rivers don't generally cut downward into the solid rock, so today's river erosion seems incapable of explaining rock canyons. The Great Flood of the Bible, however, provides a possible explanation for such canyons. On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that went at 5.1 on the Richter scale. The loud blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and a power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption of Mount St. Helens, scientists are mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100
dropped bark to the bottom of the lake, accumulating up to 3 feet of bark paint in just a couple of years. And vertically flowing logs sinking to the bottom of the lake resulted in buried trees in only a decade. Similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. At Mount St. Helens, a single mudfall off the mountain carved Engineers Canyon out of soft sediment in a single day, 100 feet deep. And the same thing would happen in solid rock. A series of mud flows created wood and step canyons on the front face of Mount St. Helens, cutting hundreds of feet into solid rock over just a few years. Grand Canyon is a good example where we find evidence of catastrophic forces at work. Upstream is evidence of huge lakes. These lakes would never have formed if the canyon were already open or open. However, if these lakes had formed from rains after most flood, and if the pressure of these waters broke through and carved through the recently deposited sediments, then we would expect to find surge deposits downstream. Below Grand Canyon, this is precisely what we find. Evidence of a lot of water cutting over a little bit of time. Even though Mount St. Helens is a very small catastrophe compared to the flood or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most common